In last video we saw what are Markov chains. Now we'll move on to HMMs, that is hidden Markov models. Now these are very crucial topic in data science, and most of the some crucial algorithms uses hidden Markov models in the implementation. So let's understand what are hidden Markov models. So if you remember recollecting from the Markov model video, we remember that it is more a Markov chain is more of an ecosystem where we have multiple states and their transition probability. So how we can transit from state 1 to state 2, state 2 to state 3, state 1 to state 1 itself. So that ecosystem is represented by a Markov chain model. Now, eventually, in hidden Markov chain model, at time what it does include is that at times we have two set of states. One are observable states that can be observed in the environment, and second thing are non-observable states, the states that can't be directly observed in the environment but can be derived from the observable state. So, like for example, look at this diagram where we are considering the weather of a day. That is, either it can be rainy or it can be sunny. Now, depending upon the weather, we are having three hidden states, that is walk, shop, or clean. So these states, so we do these states are not directly observable in the environment because the environment considers the weather information. But there is some hidden states that we are considering, that we are trying to derive from the observable states. In a Markov model, if you remember, we have just three observable states, that is the weather. But in case of hidden Markov models, we have some hidden states present that are dependent upon the observable state. So depending upon the weather, we would be going to walk. Depending upon the weather, we would be either going to shop or clean also. So let's understand this particular hidden Markov model. So the lines that are not dotted, that are solid lines, represents the Markov model, represents the transition probability. If you remember, so transition probability basically means that the probability of moving from state 1 to state 2. So if we are standing at rainy, so we have a 70% chance, a 0.7 say 0.7 probability to come to rainy next day also. Similarly, in case of rainy to sunny, we have probability 0.3%. Now the dashed line you can see, going from rainy to walk, going to shop, and to clean, we can see that these are emission probabilities. So basically, emission probabilities are the probabilities of transiting from a known state S1 to an hidden state H1, you can say that. So eventually there are two types of apart from the initialization probability that we discussed and the nodes. So in case of hidden Markov models, we have four major terminologies. One is the states S1, one are hidden states that are H1. Some initial probabilities, as you can see in the diagram, we are starting from with zero knowledge. So the initial probability of having a rainy day is 0.6, and initial probability of having a sunny day is 0.4 when we don't know the current dates weather. Then there is transition probability, that is transiting from the current state S1 to next state S2. Now the current next state S2 can also be S1 only, as you can see here. Now the new term that is coming in hidden Markov models is the emission probability. So emission probability basically means transition from the known state S1 to an unknown state H1. So as you can see that rainy to shop is 0.4, rainy to walk is 0.1, rainy to clean is 0.5.